Okay, so good morning to our grade 8 Makati Science High School students. This is going to be our first lesson for our subject geometry, and it's all about polygons. Okay, let's start with this challenging problem that would most likely be one of the problems that you might encounter in your exam. Okay, so let's try this problem. Okay, for the first one. In Pentagon ABCDE shown in the diagram below, AB is equal to 5. So what is the value of EA? Now we have some clues here. BC is equal to 6 and CD is equal to 2. Now most of these clues don't make sense on their own because this type of pentagon that we have here, it's not a regular pentagon. Okay, so it's a non-regular pentagon. Okay, so how would you classify a pentagon if it's regular? How can you say if it's regular or not? So a regular pentagon needs to have, or any pentagon, or any polygon with 5 sides should have an interior angle sum of, if you're going to try to recall the formula, so that's 180 times quantity n minus 2, where n is your number of sides. So that should be 180 times 5 minus 2, which should give us 180 times 3, which should give us 540. Let's be sure. Let's use our calculator. 180 times 3, so that should give us 540. And since there are 5 sides in a pentagon, we have to divide this by 5. So therefore, the value of each angle here, or the value of the individual interior angle measurements, should be 108 degrees. And for the case of this pentagon, they are not 108 degrees. So therefore, we can conclude that this is a non-regular pentagon, and this formula is not going to work. We can't conclude that all of them would have the same side measurements. Okay, so if we cannot conclude that, let's try to erase those markings. We can't conclude that, so what can we do? What can we do in order to solve for the value of EA or AE? Okay, so for this problem, we have two clues. The first one being that BC is equal to 6 and CD is equal to 2. The second clue would be thinking outside the box. So how can you think outside the box for this problem? Okay, so as we can see here, we have here this pentagon. And this line here, this line DC, you can extend it on one side, and you can extend it on the other side, line segment DC. Okay, now you have this long line that's the extension of DC. And this E here, you can extend it over here as well, and you will create a triangle. And this point B here, you can extend that as well, and you'll create another triangle. Since this 120 degrees has a supplement, is forming a linear pair and has a supplement with angle D here. So therefore we can say that this should be 60, and this is 60 as well. We can also say that this is 60 degrees, the adjacent angle to angle E, and this is 60 degrees as well. Okay, so since both of them are 60, this must be 60 as well, and this must be 60 as well. 60. So therefore we have two equilateral triangles here. And there's actually a third one. Let's try to use a different color. The third equilateral triangle would be this one, this entire triangle. Now, why is this an equilateral triangle? If you look real closely at the given, you have here 60, 60, and 60. Equilateral triangles have equal angle measurements. So therefore, we have 3 equilateral triangles. Now, we have seen that we have here 3 equilateral triangles. So let's try to create like a neater version of this. Let's try to erase the markings that we created. Okay, here. There you go. Okay, so again, let's just try to write neatly our angle measurements here. Okay, so here we go. So we have here 60. This should be 60. And this should be 60. And for this side, you should also have 60 degrees, and this should be 60 degrees. Okay, so since we have three equilateral triangles, let's try to write the relationship of their line segments. So we have here, for this figure, let's name this as point F. Let's name this as point G. So therefore, we can say for this problem that EF is equal to FD is equal to ED. We can also say, okay, we're done with this triangle. We can also say that BC is equal to CG is equal to BG. Okay. And we can also say that AF is equal to AG is equal to FG, okay, for this problem. Then since we have here AE, okay, we can say that for this problem, we can say that AF is equal to AE plus EF. We can also say that AG is equal to AB plus BG. And we can also say that FG is equal to FD plus DC plus CG for this problem. Okay, since we know that this big triangle over here is an equilateral triangle, therefore all of the side measurements here should be the same. All of them should be the same with each other. So therefore we can say that AF is equal to AG is equal to FG for this problem. Now, since these three sides are all the same, okay, again, it's an equilateral triangle. All of their angles are the same. Therefore, all of the side measurements are the same. So therefore, we can say that AE plus EF is equal to AB plus BG is equal to FD plus DC plus CG, okay, for this problem. Now, we said that BC is equal to CG and BG. So since we have here BC as a given and we have here BG, we can say that AB plus BC is equal to AE plus EF, okay, for this problem. And since you've already said as well that FD is equal to EF, we can say that EF, we can substitute EF for this one. And we also have here DC plus CG. So we can write here DC and then CG. Okay, so CG, we've already said that CG is also equal to BG and BC. So we can say that CG could be equal to, okay, so again we have CG. CG here could be equal to could be equal to BG, okay, for this one. Okay, and since for this problem it could also be equal to BC, okay, we can say that this should be also equal to BC. Okay, so therefore we can say that AE plus EF is equal to, we can skip this part since we won't need it. Okay, it's equal to EF. Okay, it's equal to EF. Okay, EF plus DC or CD. Okay, so let's write that as CD plus BC. Okay, since we have here CD and BC already, and we have here EF, we can transfer EF to the other side, and that will lead us to canceling EF for both sides. So EF minus EF plus CD plus BC should be equal to AE, based from our logical assumptions. Again, BG could be equal to BC. I just replaced BG with BC. BC for this problem. So therefore, this cancels out. Therefore, AE is equal to CD plus BC. And since we already know the value of CD, it's equal to 2, and the value of BC, so that's equal to 6. So according to their logical equivalence, or from the logic method that we used here, therefore we can say, can be concluded logically speaking, that AE is equal to 8 units. Okay, so for this problem. Okay, so we didn't really individually measure all of the side measurements, but from the logical equivalence and equations that we created, and based from all of the angle measurements that were given, that we derived from the linear pairs on the Pentagon. So this should be the value of AE. So AE is equal to 8 units, and that's how we solve this problem.